Malaysian Basin. Malaysian basins are structurally complicated because their assessment through different phases of continental accretion, rifting and mountain building. The geology of the Malay Basin is very old and different at the other part of Sarawak and Sabah Basin. Geophysical and geological challenges include, fine sand imagery, often beyond seismic resolution, imaging under gas chimney and under carbonates, diffraction imaging, imaging of the internal architecture of the basement, understand the propagation of waves in efficient media and the associated anisotropy, speed analysis and anisotropy, gas cloud imaging using complete waveform inversion, and multiple elimination. The focus of research in this part of the world is to enhance the image quality of the faults, fracture and karst using diffraction imaging. A shows the geographical location of the area which is near to the Borneo mainland and a part of Sarawak Basin. B is the cross-section taken from Malay Basin subsurface geometry, which is an extensional regime, and because of the tectonic activity the normal faulting can be seen. A. Location map of the Sarawak Basin and, B. A cross-section of Malay Basin subsurface structure. Fractured basement located at a depth of 2.0 to 5.0 kilometers, varying with lateral extension. Sarawak Basin. Diffraction imaging analyses were carried out in the Sarawak Basin, located northwest of Borneo, forming the southern boundary of the Oligocene recent basin of the South China Sea. Its tectonic evolution has been almost matched by seabed rifting and spread in the marginal basin of the South China Sea. The majority of the Sarawak Basin, including this part of Malaysia, is composed of carbonates, making seismic imagery difficult. The pre-carbonated Oligocene deposit in the lower Miocene and later the terrestrial deposit filled the shelter zone in Cycle I and Cycle II. The cycles are described as follows: Cycles 1 and 2, Upper Eocene to Lower Miocene, have been interpreted as channel sands, lowered clays, and deposited coal. Cycle 3, Lower Middle Miocene, contains fine limestone shale and sandstone. Cycle 4, Middle Miocene, is composed of limestone with few mixed clastics. Cycle V, Middle to Upper Miocene, is recognized as limestone. Cycle V to Cycle 8, Upper Miocene to Pleistocene, is composed of open marine and coastal clays and sand, respectively. The progradient sediments from Cycle V1 to Cycle 8 have gradually stifled the large accumulations of carbonates to the present day. In the center of Laconia, carbonate deposits began at the beginning of the Miocene, Cycle 3, and increased significantly in the middle and late Miocene cycles 4 and 5. The structure is dominated by a simple extension phase in S-trend faults. These faults affected the deposits during cycles 1 and 2 and served as foci for the development of carbonate reefs of cycle 4 and 5 and their accumulation. The dominance of intensive pre-carbonation structuring has therefore resulted in poor seismic image quality.